Okay, so I think we wrote this one down yesterday. If not, write it down now. And then we're going to look at graphing this piecewise function. For which values are we using negative x? Which values are we using this top function? Remember that on the right side, that tells us when we're using it. So we're using it anytime x is less than 0. We're going to use x squared anytime x is between 0 and 1. And we use just 1 anytime x is greater than 1. So now if we're thinking about like a chart or just drawing a line even, I'm going to move this down so I can see it. Anytime x is less than 0, we're using negative x, right? So if x is negative 1, what would that give us for our y value? If we're using x is negative 1. What did you say, Glow? Yeah, it would be 1, because we're doing a negative of a negative 1. So that makes that positive. Yep. And what about? Yeah. So now we can just plot this on our graph. Negative 1 is 1, negative 2 is 2, and negative 3 is 3. And we can draw a line in between those. Does anybody know what the end would look like? Where it comes to 0? It's got to be an open circle. You know why it would be an open circle? It's because this is just a less than. If that was less than or equal to, you would have a closed circle. All right, now any value that's between 0 and 1, we use x squared. So if I do 0.1, that would be 0.1 squared, which is 0.01. If I did 0.2, that would be 0.04. And you do that all the way going up to 1. But then 1 would just be 1. So it kind of curves a little bit, not like that. So it's going to give us a little curve in there, like that. Then if I look at my endpoints, there's an equal sign under each inequality. So now this, when if I put in 0 squared, that would be 0. So that's going to now shade this dotting from the middle one. And up on the end, oh my gosh, at 1, it would also be closed now. Because of this equal sign. What if I plugged in x equals 2? What would my y value be? Anybody have any thoughts on that? It comes, what were you going to say, Des? Okay. It comes back up to this piecewise function. So if x is 2, which one would I use? The first, second, or third? You're right. It's the third. Because x is 2, 2 is bigger than 1. So what would my y value be? It would just be 1. So when x is 2, y is 1. What about when x is 3? Right, because I don't have to plug in x in here at all. It's just giving me this number. So it's always going to be 1 whenever it's bigger than 1. So this is the graph of my piecewise function. Now, luckily for you, you're at home, and I don't want to see these ugly graphs you draw on your notebooks. They're hideous. So what you should do if I ask you to graph a piecewise function is you should go to Desmos. And you should sign up or log in and then go graphing calculator. And now this will give us a template where we can actually put in the values of this piecewise function. We just set it in 3 different ways. So our first part of the piecewise was negative x. And that was when x is less than 0. But to do it, I think you have to put these curly brackets in. So you put whatever your function is in first, and then in the curly brackets, you put your restriction on. So it's when x is less than 0. Then the next one was x squared. Whenever you do x, and then shift and 6 to get the little caret squared. And then we do our curly brackets and restrictions again. And that was when it was between 0. When you try to type less than or equal to, do the less than symbol and then equal to after it, and it'll automatically drop that equal sign under it. Now look how pretty that turned out. You got red, white, and green. It's a really nice graph. It's not like your ugly drawings. I mean, I know mine was perfect. Look at that. Looks just like it. But now, like, if you wanted to submit this for your homework, like let's say this was problem 1 on your homework, you could title this problem 1 as long as you're signed in. And then if you wanted to submit it, just in your comments in Google Classroom, click Share Graph, copy the link down, and you could just put the link in your comments. And then as soon as I click on that link, it takes me directly to your graph. That's so nice, isn't it? All right, well, don't be as excited about it as me. That's fine. Just a math nerd, I guess. I'm talking to everybody. Like, I swear. Okay. I got great ears. Cool. The greatest integer function is the function whose value at any number x is the greatest integer that's less than or equal to x. That's called the greatest integer function, or the integer floor function. So think about this, like the way to think about floor functions would be like this. Let's say you owe me like $2.40, right? So you owe me $2.40. And I say keep the change. Just pay me the bills. How much would you give me? You owe me $2.40. And I say just keep the change. I just want the bills. Right. So you're only paying me back $2. That's exactly what a floor function is. It says anything that's a decimal disappears. You're, I do hear you. Good. You go after it. It's any number that's after, it's a whole number that's after the decimal that we have. So it's the function whose value at any number x is the least integer or whole number that's greater than the number we have. That's a ceiling function. So what's the smallest whole number that's bigger than 3.8? Exactly. Exactly. Yep, you're just rounding up. Yep. If the whole paragraph confuses you, then I would just write the numbers down. But make sure you write that it's a integer ceiling function. That way, if they ask you for a ceiling function in the homework problems, you'll know it's talking about this one. What are some examples in life where you would use a ceiling function? What'd you say? Let's do it.